In the real world, forces rarely exist in isolation. Everything is an interaction. When you kick a soccer ball, your foot applies a force to the ball, but the ball also applies a force back to your foot. These interactions, whether it's a collision or a simple push, are what change motion. By asking the right questions, we can predict the outcome of any force interaction. The foundation for understanding force interactions is Newton's third law of motion. This law is famous. For every action, there is an equal and opposite reaction. This means that forces always come in pairs. If object A pushes object B, then object B pushes back on object A with the exact same strength force, but in the opposite direction. Let's use a simple example to identify these force pairs. If you push on a wall with your hand, the action force is your hand pushing the wall. The reaction force is the wall pushing back on your hand. If you push hard enough to feel pain, that means the wall is pushing back on you with an equal force that is strong enough to cause that sensation. To investigate these interactions, you need to ask a good scientific question. These questions shouldn't be answered with a simple yes or no. Instead, they should focus on a cause and effect relationship. A strong question might be, how does the type of surface affect the friction force that slows down a toy car? This sets you up to predict and then test a variable. Once you have your question, you make a prediction. A scientific prediction is not just a guess. It's an educated statement about a future outcome, informed by physical laws like Newton's laws. Your prediction must clearly state the expected result of the force interaction and must be testable through an experiment. We can start making predictions by looking at balanced forces. If you see a stationary object that is being pushed by two people with equal strength, you can predict that nothing will happen. If an object is already moving and all forces on it cancel out, friction and air resistance equal the engine's push, your prediction is that the object will continue moving at a constant speed. No net force means no change in motion. The most exciting predictions involve unbalanced forces. If the forces aren't equal, one side is stronger, creating a net force. You can predict that the object will accelerate. It will speed up, slow down, or change direction in the direction of the stronger force. The amount of that acceleration is governed by the F equals m times a relationship. Let's predict the outcome of a tug of war. Team A pulls with 100 newtons and Team B pulls with 90 newtons. The question is, which way will the flag move? You predict it will accelerate toward Team A. The net force is 100 newtons less 90 newtons, which is 10 newtons toward Team A. That 10 Newton net force causes the acceleration. Every real-world interaction involves friction. Friction is the sneaky force that always works against the motion. If you push a box with 50 newtons of force and 10 newtons of friction is pushing back, your question should lead you to calculate the net force. Your prediction, the net force will be 40 newtons, and the box will accelerate according to that 40 newtons. Remember that mass plays a huge role in predictions. If you apply the same small force to a marble, which has a mass of 0.1 kilogram, and a heavy bowling ball, which has a mass of 6 kilograms, what happens? Your prediction is that the marble will accelerate much, much more because it has less mass. The smaller the mass, the greater the acceleration for a fixed force. Think about standing up. Gravity is pulling you down, and the reaction force from the floor is pushing you up. This is called the normal force. If you ask, what would happen if the floor only pushed back with a force less than your weight? Your prediction, based on unbalanced forces, is that you would start to break through the floor and accelerate downward. Let's predict the result of a collision. Cart A and Cart B have equal 1 kilogram masses. cart A hits cart B at 2 meters per second. Because of the third law, cart A pushes cart B forward, and cart B pushes cart A backward with the exact same force. Since their masses are equal, you can predict that cart A will stop or reverse slightly, and cart B will move forward at about 2 meters per second. When writing predictions, use the greater than sign or the less than sign. These signs make your prediction very precise. For example, if you predict an object will move, you are predicting that the F applied is greater than F friction. If you predict it won't move, you're saying F applied is less than F friction. Let's predict what happens to speed. If a car is already moving, and the force from the engine is greater than the total forces of friction and air resistance, what happens? Your prediction should be that the car will speed up. It will accelerate. This is because the net force is in the forward direction. Forces can also change direction. If a tennis ball is flying to the right and a bat hits it with a strong force directed up and to the left, your prediction is that the ball will sharply change its path and move up and to the left. The acceleration always occurs in the direction of the net, most powerful force. A great way to test your understanding is by asking comparative questions. These questions ask you to compare the outcomes of two different scenarios. For example, which scenario results in greater acceleration? Pushing a 2-kilogram object with 10 newtons or pushing a 4-kilogram object with 10 newtons? Your prediction has to state a clear winner. To solve that comparative question, we use A equals F divided by M. Scenario 1 gives 10 newtons divided by 2 kilograms, or 5 meters per second squared. Scenario 2 gives 10 newtons divided by 4 kilograms, or 2 and 1 by 2 meters per second squared. Your prediction is confirmed. Scenario 1 results in greater acceleration because of the lower mass. To make a high-quality prediction, use this simple checklist. First, identify the net force direction. Which way is the overall force pointing? Second, consider the mass. Is the object light or heavy? Third, determine the resulting motion. Will it speed up, slow down, stop, or change direction? A prediction that covers these 3 points is solid. Remember, predictions are not just homework. They are vital to science. They give the experiment purpose. If you predict an object will accelerate at 5 meters per second squared, and your experiment confirms it, you've strengthened the evidence for Newton's second law. Science progresses by making predictions and testing them. Here is a final challenge. A hockey puck is sliding on ice, so friction is very low. It is given a small push, and then the push stops. What happens to the puck's motion after the push ends? You predict it will continue moving at a constant velocity because the net force will be close to 0 newtons. With no net force, there's no acceleration, proving Newton's first law, which is just a special case of the second law.